All right. I apologize. I might actually have some typos in my presentation, but I will go nevertheless and share what I have. So, uh, one second, guys. You will see this shortly. And let us share my screen. Hello, everybody. If you can hear me fine and I'm not too loud, can you give me a 1 or give me a 2 if I'm too loud in that sense? Give me like a +1 in the chat if you guys can hear me just fine. Um, so I can start us off well. Perfect. I get some +1s, just a regular 1. That's great. All right, so you can see this. Today we're going to be talking about gas optimization techniques. What is gas optimization techniques is basically we're saving everybody money, basically whenever we're talking about in terms of the blockchain. So this is a very high level overview of how we're just going to do gas optimizations as it relates specifically to memory as well. So again, this presentation, you can go really, really deep in terms of a rabbit hole as to what you can do for gas optimizations. I will be sharing the link to this presentation a little bit after because I realize that there is a small little typos within the presentation that I'll try to fix up, and I'll send off the URL. I also like to be able to kind of give some stats behind this presentation, so bear with me. I will send off this link afterwards, so feel free to take notes with this, but at the same time, we'll be going into a little bit more detail in the finalized version. So briefly, just about me, if you guys haven't heard, and maybe you guys this is the first time seeing me, or you have seen me before. So I'm Manny, or Coding with Manny. I'm a developer relations engineer with Polygon. My mission is really to empower developers such as yourself, every one of you guys right here, like everyone here, to be able to do better in terms of programming or understanding the blockchain in that sense, and just being able to give you guys the tools that you need from like a high level or even a very specific level. If you guys have any questions for me, typically, feel free to at me publicly on Twitter. It's a great way to be able to start a conversation, and also a great way to be able to kind of get people to participate in the conversation. As much as I would like to admit that I know everything, unfortunately, I don't know all aspects of everything. That would take a long time to learn every aspect of it. So I will admit there is some things that I probably don't know enough about, but I try my best to be able to kind of give everybody what they need in terms of understanding. If you don't know me, follow me on Twitter, definitely at Coding with Manny. I'm the same on Instagram and a few others, as well as Discord and Telegram. Feel free to follow me in that sense. But we'll start and we'll begin. So first off, to be able to understand gaps optimization, like the first thing that we need to understand is like what is gas essentially. So what does that mean? So the way that we measure it actually is in Wei. So, or otherwise known as Gigaway. Basically, it's a 1/1000th of an Ethereum of the actual token itself to be able to measure how much a transaction costs. So when we are referring to Wei or Gigaway in this sense, we're referring to basically the fee that's needed to process a transaction on the blockchain, whether or not even to deploy a contract or to even process a payable, like a written transaction to the blockchain. These are usually calculated in Wei. So that's as a good basis. You want to understand that, hey, going forward, when they say gas, when they mean Wei, it's the number of units in terms of 1/100000th. And I use this example, like think of a highway. If you're going to go down a highway with a toll, you're going to pay for that toll to use that highway in that sense. So in the sense that if you want to deploy a contract, if you want to interact with that contract, you might have to pay a certain amount of money, in this case, Wei or Ethereum, to be able to interact with that. So as a base unit, just understand that that's a basic understanding of how, what unit we're dealing with to be able to kind of measure. So everything that we do referring to this refers to the number of gas that we're going to be optimizing. And it's always a good place to start to say, hey, what's the unit of measure if we're going higher or lower in terms of our metric of success and ideally we're aiming for something that's a little bit lower. So um, to start off, like we got to understand the building blocks of what will help us use like for the right tool for the right job, right? So, and we're gonna look at storage specifically, right? Some of these these are like gray areas in terms of the answers, but again, I'm gonna go through each one of them. So the way that the Ethereum virtual network machine and whatnot essentially processes your contract, there's about like 6 different ways that it kind of handles memory in the sense, right? And I'm gonna go into this a little bit more in terms of understanding, what each one of them mean and what does that mean in terms of specifically optimizing for each, right? So let's start off with the stack. So the stack is really being able to process transactions. There's actually about not transactions in terms of the blockchain, but in terms of number of basically commands or operations that you can kind of do with in a temporary memory that kind of deals with specific commands. So we'll go into that, but the idea behind that, the stack is actually you can actually write this using assembly and operation codes where you can read read some of it and you can actually write to it. And the storage is kind of temporary. You can actually interact with it on a permanent basis as well, but the idea is that the stack is really temporary. Once it's done and whatnot, then you're basically done with that. The memory side of things is really, you can think of it as your computer and that in your central processing unit. You have your memory. It's very temporary, right? The idea behind this is you really want to be able to, when you're processing a specific transaction, you're trying to do all these calculations or whatnot, you probably want to do that in temporary and not be able to kind of store that permanently on the blockchain. So you think of this as like, you can read to it, you can write to it, but it's very, very temporary in the sense that once you're done with it, essentially that memory is kind of let go. And storage in this case is your permanent storage. So this would be related to your blockchain in the sense that, hey, I can read to it, I can write to it, but it's the most expensive out of all these storage in terms of gas that's needed, right? So you typically want to do this when you for sure want to be able to use permanent storage, right? So the next up is call data. So similarly to memory, it is actually a more efficient way to be able to kind of process transactions in terms of temporary operations you're kind of doing within a function. But the only difference is that there's some caveats with it in the sense that call data can only be accessed from a function, and it can only be you can only read from it essentially. So think of like a function where you have like function has an input of A, and it's set to call data. Typically, you might not want to, if it's set to memory, you can actually modify that existing variable. In this case, with call data, you can only read from it. And this is just another way that you would be able to be a bit more efficient. Code in this sense is really the actual code you're dealing with that's actually executed on the EVM, so your Solidity contract. So you're not necessarily, it's not interacting in the sense of read and write, but it's something that you want to factor in the sense that, hey, once it's gone through, it's kind of permanent in the sense that you don't necessarily interact with it in the sense of being able to store data to it, etc. But it is something that's factored in with it. And logs is another aspect of stored memory where it is, you can't read from it, but you can write to it, but it is permanent. So logs are great, or event logs are really great for a way to be able to do indexing, or potentially just a way to be able to not have to store data directly on the blockchain in a way that is very, very expensive. But if you're just trying to find information or find logs of data or historical data, this is a great way to be able to store it and much more gas efficient in that sense. So these are probably the 6 main ways of storing data in the sense of how the EVM kind of like, or the Ethereum virtual machine kind of compiles and understands and interacts and executes with this type of data. So let's dive into each one of these to kind of give you an overview as to how that looks like in terms of it. And some of these I won't go too deep into because I wanted to give like a semi high level overview of it, but I'm giving some links as to what you guys can kind of go from there to be able to essentially find out more information from it too. So the first thing is like their stack. So we talked about the idea of a stack is really a list of commands that they're able to kind of put put essentially push into it, and then you can pop it, or you can add, you can do basic multiplication, mathematics, etc. It's a great way to be able to do very, very simple mathematics as well. So opcodes or operation codes is the most cost effective way to be able to interact with variables. And this is something you can actually do within your Solidity contracts, right? So each one of the slots or whatnot, or each one of those are about 256 bytes or 32 bytes of data that you can store. So this is one caveat of it, is that, it's a very, very efficient way to be able to do, those multiplications or that type of variable manipulation. But at the same time, there is some heavy limitations with it. And the stack is limited to about 1,024 slots. So if you're trying to do multiple types of interactions with, you know, multiplication, etc., and you're adding, but you hit that 1,024 different slots, there's a good chance that there's going to be a stack overflow, in the sense that it'll break. So you typically want to add things and then remove them. But I definitely recommend looking into this as well. If you guys have a chance, go to evm.codes. There's a really interesting way that they can show you a playground of how basically what happens, how your contract actually gets converted into opcode. So technically what happens is when your contract is actually compiled into a binary, and that binary is actually a set of operation codes. And it's the most efficient way for it's actually going to communicate, so that how to interact with the contract in that sense, right? But you can actually write those commands directly within your Solidity contract, and it's a very effective way to be able to do, temporary type transactions, to be able to be, more cost effective with your transactions. So I definitely recommend looking into that. The next step is, and I'll just say this about opcodes as well. It's a very big topic. There's a lot to go into with this. So look up, if you got a chance, in terms of assembly, the keywords assembly, operation codes or opcodes, EVM stack in that sense. It's a very, very, you can get into a rabbit hole of different types of operations, things that you can do with this, but it's a very interesting way to be able to redo an entire contract only with operation codes, which, makes your contracts essentially more gas effective. Next up is like memory or temporary memory. So this is you can store memory to, like you can take permanent storage and kind of put it into temporary memory in that sense. It'll usually be cheaper, most of the time be cheaper, but you want to avoid caveats where you're like adding a ton of arrays, like a huge array, copying over in terms of temporary memory in that sense. The one caveat with this is you'll notice that with memory, they're really in the form of arrays. So it's not like you wouldn't necessarily do like a regular like string or a regular uint by itself. It's really kind of reserved for arrays. But what is interesting here is, if we use this example, this is actually an example contract that was given by Patrick Collins as well, on 3 different ways that are actually most gas efficient. So the first version is like what we see here in terms of line. We'll go line 5 to 6. We're initiating these 2 variables that are permanent storage variables, whatnot. Our constructor is essentially initiated, and we set that permanent storage for these particular values. It's going to do the sum of each one of them. So function A is a typical operation that you would do in terms of, I just want to do a sum of all the values, right? And if we look at it, we're going through an array here. Through each one of the items, we're going array funds. So we're calling the permanent storage array length, and then we're going to the total funds, and we're just going to increment total funds plus whatever that array amount is. So that's typically how you would do things. But if you look at it, option B will explain why there's a more efficient way to be able to do this, right? And one of the most efficient, a base efficient way is actually to use a temporary type of memory variable declaration in this sense. And if you look at it here, we're going to uint. We're declaring a temporary variable in this sense. We're going through an array, and then we're just incrementing that temporary array. And once we're done with all those transactions in that sense, and everything is into memory, right? Then we're done. We're going to actually put it back into the permanent storage in that sense. And what this does is like, as long the goal with this is you're trying to do is you're trying to avoid as many reads and as many writes to any permanent storage. And you'll find that this is actually a very effective way to be able to reduce the amount of gas for your transactions, right? And you can actually take this a step further in and basically in option C here, where we take even an array, a temporary array for a variable declaration, and we make a copy of the array funds. Now, this is small enough so that it might make sense to kind of copy it over. If it's really big, then you might want to use something like pointers to be able to kind of point to specific items that you're looking at. But in this case, you're just copying over the existing array, and then you're just incrementing based off of that temporary array funds in this sense, and going through. And you'll see that I'm not referencing where you see on line 20 the original permanent storage. In this case, I'm just referencing the temporary variable in this sense. And this is a step further to be able to make your contracts even more gas efficient without having to, avoiding the usage of reading and writing of permanent storages as well. So I highly recommend when you're using like temporary, like memory is a good way to be able to kind of copy over whatever personal storage is. And then be able to manipulate that. And then when you have your final state, then you put it into that final storage, right? So that's usually with temporary. All right, so next up, we can even actually do optimization within loops as well. So one of the things is, you'll see an example here. This is actually a typical loop that you would do. You do your num plus 1, but you'll see in the last example, I just want to reiterate that if you do actually copy over that number within temp and be able to do the modifications within that temporary variable and then finalize it, this is a very cheap way to do it. One trick, and I did put it in here, that you can actually do as well is it saves in terms of optimization gas a little bit more, and I'll modify these slides to show it as well, is that you can actually put uint I outside the for loop as well to be able to optimize it even further. So if you actually declare outside that for loop, that's one way to be able to kind of optimize the gas cost for this specific function one step further. So that's like memory and loops in that sense. All right, so next up is like, well, what would be the case for permanent storage, right? Permanent storage, again, is really in the case like you're not doing like big modifications to it. The idea of permanent storage is really you're only going to use it in the case where, hey, I absolutely need to be able to have this persist, and I might need it to be a little bit more secure. So like if security is an aspect of it and you don't necessarily want everybody knowing about that specific data, but it needs to persist, that would probably be the way that you want to use permanent storage. And a good example of this is, an ERC 721 contract, where we kind of define who are the owners of specific NFTs. And with that, you're able to kind of go back and say, hey, this is the actual user that owns this particular type of NFT. And it would be good to kind of keep that on permanent storage and know exactly who that is. And it would be the same for ERC20 tokens, or if you're doing signed transactions directly to a contract and you don't want those signatures to be seen in that sense, or a way to be able to store that permanently, there's ways that you probably want to take advantage of that permanent storage. So these are more use cases for it. But again, if you can, avoid it as much as possible. Try to do constants, temporary memory storage. These are effective ways to be able to use storage so that you can minimize the amount of gas that you're going to use with your contracts. All right. Next up is temporary call data. So if we looked at this is a simple example, but it's something that you can actually see that there's a difference between the call data here, is that all I'm doing is I'm not doing any modifications to rewards in the sense that where it's expected to be able to expected in an array of a memory of uint. Here on line 6, you can see that I'm returning that memory back of that function. But notice that we're not doing any modifications to it. So if we're like expecting a result and then we might add some modifications and we're not modifying it directly, then why would I need to be able to make it a memory? Whenever possible, the most effective way to be able to use another way to be able to do gas optimization is really to be able to use call data versus memory in that sense. Because again, we're not using any any modifications to that original rewards array, we're just returning it back. And if we did modifications to it, we can even in there create another memory function, which would just optimize for those inputs too. So it's a great way to be able to a great way that you should incorporate essentially within your contracts to, if you're thinking about it, it's like, if I'm going to modify this, maybe I should use a call data in that sense. So that's call data. Next up is code. So this slide is very, very simple. And I'll give you some tips as to why actually this matters and ways that you can kind of optimize for this, right? So code is really for the EVM to be able to kind of process. And the main way that you can optimize for this is just the amount of code that's within your Solidity contracts. And one way that you can do that is there's a few tips that I have here. So one, the first thing is, like, typically as developers, we kind of go into things thinking, oh, well, we got to optimize day one in that sense. My advice for you going into this, if you're building a Solidity contract, is build it out exactly as it is. Try not to over optimize from the start. What you want to do is try to get your MVP or your minimal viable product with your contract. And once you're at a point where you're like, hey, this is looking great, this is exactly what I needed to do, then you work on your optimizations, because what you'll find is you're thinking less about the actual product or the final contract versus as opposed to just looking at optimizations, and you'll realize that you're not actually achieving essentially what your contract is supposed to do. Unless your contract is trying to do a most cost-effective way for an exchange, then start with the exchange aspect of it, and then try to figure out a way to be able to optimize it afterwards. So that's like advice number one, is like, try not to over-optimize to start, right? The second is what you can actually do to optimize your code to is, this is going to sound really, really simple, but go through your contracts. And even if you're using like an Open Zeppelin like template, or if you're using a third web template to be able to define an ERC20 token or a 721 token, if you're going through it and you're realizing that there's a whole bunch of functions that are existing in there in that template, right? But you're not utilizing them, but you're still adhering to the 721 standard or to the 1155 standard, then think about removing some of that dead code, essentially removing that code that is not necessarily needed for a lot of things. And you'll find that once you start removing back and tearing down some of those functions, you're removing a ton of code that would be great for gas deployment, and also essentially for gas interactions in that sense too, right? So think about it this way: when you're doing a 721, I definitely recommend for anybody on this call, like, if you haven't done so already, take a 721 contract like Open Zeppelin, go through that template, right? And if you're seeing a function that doesn't necessarily need to be there, or you think you're not going to be using it, or if you're not using enumeration in that sense, right? Like, figure out a way to be able to cut it down and able to remove some of that code that you don't think that you're going to be using, right? Transfers are definitely needed, but if I definitely recommend going through it, dissect it yourself, do it with an ERC20 token. Even it'll be a little bit simpler, but see what's absolutely needed, or ways that you can kind of optimize it so you don't necessarily need all that code for that code deployment as well. So that's 5. And then the last one is logs. So this is like the easiest thing that you can kind of do within your Solidity contract. So this is in the sense where you can create custom events and you can pass in data. So why would you use index logs? Or why would you use event logs? So event logs are a great way to be able to kind of get historic data. So if you're trying to say like, hey, I need to understand who transferred what token to which person, that is actually kind of built into most ERC20 tokens, and as well as to 721 contracts as well. There's event logs that are set up. In this case, this is a 320, I believe, which a transfer event is emitted, and you can actually see that data. You can pull that data through Ethers.js or some of the other Web3 clients to be able to kind of parse that data, and through some RPCs, like if you're using Alchemy or Infura or Anchor in that sense, you can actually use some of those filters to be able to process that data, that historic transaction data. So you really want to do this in the sense that, hey, like, I want to store, it's not private information, but I want to be able to show a history or some sort of linking between different types of contracts, or let's say I wanted to have a contract that deployed multiple contracts, so have a factory that creates a new contract, right? But and see that it's a flavor of a specific contract, and track how many contracts were actually deployed. Events are really great for that, and being able to track all those different types of contracts. So as opposed to having one single contract, have an array inside of it, like a permanent storage array, and you're like trying to keep up contracts, or uh, trying to keep track of, different addresses. If it gets very expensive if you're always constantly appending or updating that specific array with that's permanent storage, that I would really, really advise not doing. Where you might use permanent storage is like, hey, I might need to create a Merkle tree and a Merkle proof in that sense, and I need to store that within the contract, and I need to be able to compare to be able to see that, right? So maybe I might want to store that in the permanent storage, but even that, but as far as it goes, most things that if you want to be able to search data, if you want to be able to find historical data, I definitely recommend using event logs, because they're a great way to just publish it. It's very cheap, and then if you want to reference that contract, or all the history that's related to that contract or other contracts, it's a great way to be able to find that data through event logs in that sense. All right. Last thing that I'm going to cover here is you can actually go through, I recommend going through the Remix IDE on ethereum.org. If you go into your actual contract, and once you actually deploy it, there's actually a debug button. And for every interaction with one of your functions, you're able to see, one, the opcodes, and two, you're able to see the steps and also the gas, and the details of that, in terms of saying, hey, how can I compare these specific types of functions in terms of seeing which one is the most optimized, right? I definitely recommend anybody who's going through and taking an existing contract that they have, create a couple different types of functions that you have, that are, one is like, hey, this was my base, here's a slightly optimized version of it, and then see what the actual, when you're transacting those contracts, see the gas change between each one of them. And at least it'll give you a way, or a reference point, if you're going in the right direction in terms of, hey, am I getting more optimized with my contracts? Is there, am I going in the right direction? Am I saving gas with these transactions? And I recommend anybody doing with this, with any of their contracts, go through that process, see the difference between different functions, and actually compare the gas cost with each one. So you can do this in Remix IDE. In Hardhat, if you're doing with Hardhat as well, there is a way to be able to see it. It's called Solidity. I believe it's Hardhat Gas plugin, where you can actually see this data as well. I didn't do this, but I'll try to add this to the presentation afterwards as well. But it's a really great way to be able to actually see, hey, am I heading in the right direction for gas optimization? So that is my presentation on gas optimizations, the different ways of storing data when it comes to on the contract, and different techniques that you could use from a high level, when to use the right tool in terms of storage for the right type of data, so that you can kind of be more conscious with the gas that you're deploying or interacting with your contract. So guys, I'm sure you guys might have some questions for me. Please, if you have any questions, please raise your hand in the chat, or if you don't want to talk, feel free to type it up in the chat as well. And so I'm taking any questions. Silence is amazing. Give me a +2 if you're still alive. Thank you, Judith. Thank you, Elizabeth. You made me feel like I'm not the only person around here. Thanks, guys. Um, Anybody, any questions? Anything about resources, etc. As well. I can also handle questions, and where I can send you guys uh, um, for different ways also, where you can kind of go down this rabbit hole as well for gas optimization. Well, guys, I will say that I definitely recommend checking out Patrick Collins has a specific video on gas optimization where he talks about this. He talks about the EVM and how your contract is actually compiled into a binary file and your ABI file, your application binary interface as well. There is also a really great YouTube video from Consensus. It's a very long video about for app codes. Yes, one second. I just looked at it recently. Let me get you guys this video. All right, so this is one video that I recommend also checking out as a resource. It's it's specifically from the Ethereum engineering group. It is very long. It can be very, very technical, but I definitely recommend checking out as it goes over a lot of different aspects of the opcodes. I also recommend if you guys have a chance, definitely join some boot camps when it comes to opcodes. It's a more advanced aspect of things when it comes to opcodes. And like I mentioned before, if you go to evm.codes, and let me just share that right here, but an example of what that looks like. If you can kind of see the playground, you can see a Solidity contract. When it's run, you can actually see it being set up into different opcodes. So you can, as you run it, you'll actually see at different points how the opcodes are actually being executed. And you can kind of see the different definitions of different opcodes as well. So I'll place that link here as well. Say we can remove unwanted code like standard. How does that actually work considering that we have to import directly from OpenZeppelin? Yes. So OpenZeppelin, let me bring up this link quickly. Zeppelin, and let's do an ERC20 token. Give me a second here. Let's bring up the contracts token. Let's take an ERC20. All right, so here's an example of an ERC20 token template that we use. Again, a lot of it's a contract, but you can, some of them are interfaces. You'll notice that like some things like, some functions are needed. What I mean by this specifically is if you look at the EIP standard for an ERC20 token, and I'll just bring up the EIP and ERC standards. So let's set up ERC20 in that sense. So you'll see that these are the functions that are absolutely needed. So the name, the symbol, the decimals, total supply, transfer, transfer from, approve, allowance, e-transfer, approval. These are the events that need to exist as well as the functions that need to exist, right? So if we look at these side by side, there might be some functions that you might necessarily need, like we have total supply, balance of. Sometimes what you can do as well, if you know that you don't necessarily need to return the symbol, a great way also to be able to, that you don't necessarily have to set this, is you can have the return symbol function. Well, here in this case, you can have that. But what you could do is like line 71, if you know that you're not changing it, you could import that and remove symbol and just put a direct string. So you could actually write, return my symbol, or like my, let's just say Manny symbol or whatever. You can go directly as a string, and that would actually be another optimization because you're actually getting rid of the symbol variable that's not used anywhere else, right? So even here, you could pre-fill some of these as like actual defined strings as a way to be able to be optimized. And this is a little bit different, where what you have to factor in is sometimes when you're dealing with Solidity contracts is that the general fundamentals from other programming language is like, hey, you want to follow like the dry method, which is like you don't want to repeat yourself, right? So again, dry is in DRY, don't repeat yourself. But in contrast to this, sometimes with Solidity contracts is you you actually might want to repeat yourself, because a finite string or even a constant would actually be a lot better as to set as a variable normally within a contract. So these are different ways that you can kind of optimize for that, by saying like, hey, I can do small tweaks here and there, so that if I know these values, I'm not just trying to take advantage of like what's already there, but there is a way for me to modify it and make it my own so that it's slightly more modified. You have to remember that some of these templated contracts that are provided by OpenZeppelin and Third Web are like, they're set up to be a base to make it easy for you to deploy things. But at the same time, there's nothing saying that you can't just copy this code directly within your contract, and then be able to just modify it and tweak it to be a little bit more gas optimized as well. One other thing also to do is there's actually a functionality or feature within Hardhat where you can actually set the Hardhat config. It's a configuration within your Hardhat config that says to optimize. What this does is it when you're deploying your contract, it'll actually compress it as much as possible, so that when it actually gets onto the blockchain, you'll have a much more gas optimized contract for the deployment. So it'll be less of a cost for you as well. So that's essentially what I mean by that as well. Any other questions? You're very welcome. Even if you guys want to chat or even raise your hand within the group, I'm open to any questions when it comes to gas optimizations. Judith, thank you for being like, I don't have any questions. Perfect. Awesome. Oh, to this GitHub page specifically? The ERC20 token for OpenZeppelin? Okay. You can see all the tokens from OpenZeppelin's contract, and if you go to OpenZeppelin directly, which is link for you guys, Zeppelin. Let me just bring this up. You can actually see some of the contracts here. I'll paste this link as well. What's also neat about this is that when you go to the contracts, there is actually a wizard, which I do actually recommend sometimes doing, which might be a way to be able to optimize your contracts too. Let's see here where it is again. Let me just get the wizard. Oh yeah, contract wizards. There we go. This is I definitely recommend this as well, because sometimes, even though you have like an ERC20 token or ERC721 token, maybe you don't want it to be mintable. Like it's a finite for ERC20. It's like, hey, I don't need to be mintable. I already know what the set is going to be in terms of the supply. Maybe I don't need it to be burnable. So like, I don't need the burn function. I just want the tokens to exist and they will never be burned. So I definitely recommend also checking this out. This is a great way to be able to go through and say, hey, do I need specific types of functionality within my contracts? And that might be a way to be able to also remove some of the costs for transactions and be a way to do optimization for gas. All right. Any last questions before we sign out here? Anything with gas optimization, any other resources, etc. Again, if you guys have any questions, feel free also to follow me on Twitter at Coding with Manny. You can at me directly. I will do my best to reply to everybody publicly. It's a lot better than sending DMs. DMs are really, really hard to kind of keep up with these days, but it opens the conversation. But definitely, I recommend send me a message publicly, and I will happy to try to respond to answer your questions too. If any of you guys are if any of you are going to be in Lisbon as well at the end of this month and beginning of November, I will also be at ETH Lisbon. as well as Web Summit in Lisbon in Portugal. So if any of you are there, definitely hit me up, send me a message, say, hey guys, I would love to meet up. I would love to see if I can meet up with any of you guys as well. So if I'm Manny or Coding with Manny, I'm responsible for Europe in that sense with another guy named Raza, but we're also responsible sometimes to do events within Africa or the MENA region. So if you guys are at a specific event or Web3 event, we would love to meet up with you, with any of you, to be able to kind of talk code or talk building different types of products as well. All right, guys, I will give it a couple more seconds. Any last minute questions? Hold your last minute questions, anything when it comes to gas optimization. All right, guys. Well, I think that's it. With questions, I will do my best to be able to send off the link to the organizers, to be able to send off the presentation link, so that you guys all have a reference to the presentation. I'll do some minor tweaks to it to add what's needed as well. If you guys do have any questions, again, hit me up on Twitter, and I will make sure to send off this presentation. Thanks, guys, for this evening, and I hope to see you in the next one. Thanks, everybody. Bye.